Hey everybody, welcome back. Got a little gem for you here today. We've got another vintage speaker that somebody has sent in. And this is one that I've been asked about quite a bit. I've had a lot of people ask me if I've done any upgrades for this thing or not. This is the Pioneer HPM-100. And I know a lot of these out there. They produced these things en masse back in the day. This was a mid-70s, late 70s model speaker. And it measures a lot like you would expect a speaker of that vintage. There's definitely some issues, but there's some good things as well, though. Paper cone base 12-inch woofer, paper cone mid, there's a paper cone tweeter, and then there's a little super tweeter. The mid is in its own little cardboard cylinder that goes through this thing that's about half the box deep. Tweeter sealed back, of course, and then it's ported right out the front, which you think, well, that could cause some problems too. And it's very lightly constructed. There's no bracing in there. It is a hollow box, and it kind of has a hollow sound. It definitely needs some little bracing glued into that thing to stiffen it up, and it definitely needs to be lined with some no-res. That would help a bunch. And that's part of what I recommend with the upgrade that I did for it. But let's look at everything else first. Crossover-wise, yep, this is a 4-way design, or really more like a 3.5-way because they're really not crossing the top off of the tweeter to bring in the super tweeter. They're adding the super tweeter. The whole crossover is all built onto the binding post cup. And that's it. Some little iron core inductors with the 18 gauge or less wiring on it. 18 gauge wire leading to the drivers. Ah, man, it's just ooh, 70s, mid 70s stuff. And it's got some pots on the tweeter in the mid to kind of adjust the levels, which didn't do anything to help the response. In fact, let's look at the response. Frequency response, as you can see, it's pretty rough, and there's no way of sugarcoating it. There's a pretty big dip area there in the 1 to 3 kHz region, and then above that there's a huge peak, and then there's a big dip, and it's a total mess. And let's look at the effects with the grill. The grill sticks out quite a bit and has a little bit of an effect, but a lot of what we're seeing in the frequency response has to do with the diffraction. None of the drivers are flush mounted, they're all surface mounted. So a lot of the sound is reflecting off of these edges and reflecting off of the sharp corners. Of course, when you put the grill on there, it's reflecting off the frame of the grill. So there's a lot going on there, causing a lot of these anomalies that we see here. But back in the day, they would calculate a lot of what these values need to be, and that was all they had. Whereas today we can actually measure this stuff and see what it's doing and measure it in the off axis and look at the spectral decays, and we can address problems. So let's look at what happens as we move left to right. Now the mid and the tweeter are set up kind of diagonally. So if you move left or right, the tweeter gets further away in time or closer to you in time than the mid. And because they're crossed at a really high frequency, they cancel each other out real easily. So if you move left or right just a little bit, I mean just a foot or two over, it can drastically change the response of the speaker. Same way with going up or down. As you go up or down, the time arrival difference that you create there can drastically alter the output levels, and it can cause comb filtering all over the place. And a lot of it has to do with the fact that the crossover points are pushed up there pretty high. This little mid's covering a pretty wide range, and it's playing way too high. Let's look at the horizontal off-axis response. And if you've seen me post horizontal off-axis before, you'll know that this is probably the worst I've ever posted. Look at the red line. The red line is on axis, so we took an on-axis measurement, the center of the box at 1 meter. And in this case, we moved this direction with the microphone. So we're moving 10 degrees per measurement. Orange is the very next measurement. So look at the orange line and look how much of a drastic change it is from just moving over 10 degrees. And then the next line is yellow. That's moving over 20 degrees to green and then to blue. And as you can see, as you move just 10 degrees each way, you'll see big changes in the response. You'll see peaks where there was a dip and dips where there was a peak. And no, these don't even out in an in-room. They're a total disaster. You have hot spots in different frequencies that are just a total mess. Same thing going vertically. If you look at the vertical off-axis, again, look at the red line and then look at the orange line, and that's moving up just 4 inches. Just 4 inches. And then the yellow line is moving up now 8 inches, and the green line is moving up 12 inches. So we're moving up just 4 inches at a time, and you can see the whole top end of the speaker is just a total disaster. It's a total mess. And one more thing, as while we're talking about the on-axis response, I know you guys are going to ask me, what about the potentiometers that are right here on the front? Can't you just adjust these and change the level of it and balance this out? Just use it as an EQ to fix this response issue. No, you can't. We went 2 increments at a time, up and down, and took measurements on just the adjustment on the tweeter and the adjustment on the mid. It would raise and lower the output over a wide range, but it did not do anything to fix these huge peaks and dips. It was just as much a mess. It went further south any direction that we used it. It was still a mess. And you never want this stuff in the signal path. These are not step potentiometers. They're the worst kind. They're awful. They're going to degrade the sound. You don't want that in the signal path. So yes, we tried it. I took measurements of every single one. It was a mess. Let's look now at the spectral decay. Looking at the spectral decay, we can see that there's a lot going on there too. There's a lot of these lines that you see, these narrow band runners that just run straight out from that graph there, that indicate either ringing or a reflection or some late arrival. And now if you look at some of these traces, you'll see they start at the peak and they just come down. Some of these right in the mid-range area there that are from this driver, you'll see that it's more from a dipped area where all of a sudden a peak pops up and starts trailing out of there. A lot of times that can be from an internal reflection, but in this case I think a lot of it has to do with just the surface reflections right off of this edges and off of these drivers is what's causing some of that stored energy. It's like a late arrival. It's a mess. So first thing I looked at, and I was really worried about the drivers themselves. I thought this little paper cone mid or paper cone tweeter is maybe one of the bottlenecks, and if we dropped a good dome tweeter into this thing, that it could carry a lot of the speaker. With a good modern tweeter that would fix a lot of this. But we couldn't really find anything that fit this hole or was this big in diameter. And I thought, well, let's look at the frequency response of this thing. Let's see what's there. Let's see if it's really that much of a problem. So let's look at the tweeter's frequency response, and then under it, the spectral decay. So as you can see, a lot of those humps that are there aren't ringing or stored energy. So that was a plus. That was very promising. The one down low, you'll see there's a little bit of stored energy at that frequency, but in the rest of it, all those lumps that we see across the top, amplitude peaks, and a lot of it is probably due to the diffraction right off of these edges because they're not flush mounted. And the tweeter went down really low. It is a cone tweeter, and a lot of times a bigger cone tweeter will play down lower. In this case, it certainly did. It was good down to 1,000 hertz, and then it dropped off pretty quickly. So that was very promising. Looking at the mid, though, let's look at the frequency response of the mid and then the spectral decay right below it. And that's rough. That's really rough. A lot of those peaks you can see in the spectral decay, there is some stored energy there. Those that are down low, that's rough. And so I'm really worried, can I make it work with this mid? But since the tweeter plays down so low, maybe we can use the mid as a filler driver. Maybe we can bring the levels way down, basically, and do a tweeter woofer, and then just do the mid right in the middle. And doing like what I call a filler driver can work really well in a lot of applications. And I thought, maybe I can make that work. I don't know. It's going to be tricky. And then let's look at the woofer's response. Let's look at woofer the frequency response, and then the spectral decay. And as you can see, it's good to about 1 kHz, and anything above 1 kHz in its usage range is completely horrible. It's got so much ringing and stored energy there that it's absolutely unusable if you run it up very high. So I thought, I don't know if I can make this work or not. This is going to be tricky. So let's see what I did with this thing. Let's start with the crossover response. Let's throw that one up right now. All right, first of all, look at the red line. Look at how it's summed. We're plus or minus about 0.5 dB from one end to the other. This is probably as flat of a line as I've had on anything in here in a long time. Considering what it looked like from the beginning, I can't believe I got it to look like this. So I did use the mid a little bit as a filter driver. You can see the way they sum and where the mid is versus the tweeter and the woofer and where they roll off, how I was able to do that. And by pulling that mid down in the output quite a bit like that, we accomplished a whole bunch of things. First of all, that was where a lot of the stored energy was, and now it's been minimized by a lot by bringing the level of it down like that. And minimizing its range helped that a lot. Letting the tweeter play down that low helped out a lot. And that helped out in the fact that the crossover point, which was probably at 5 or 6 kHz, is now just a little above 2 kHz, at about 2200. Now when you move left or you move right, the wavelength at the crossover point is like 3 times as long as it was before. So when you move 10 degrees off axis, you're not making a 30-degree phase rotation between these two drivers. Now it's only like maybe a 4 or 5 degree phase rotation. You're having to move a lot further to create enough phase rotation there to where one is out of phase from the other. So it worked out really, really well. Let's take away the crossover response and just look at the frequency response with the new crossover, and then the way it was when it came from the factory. This is a transformation. This is just having the correct tools to look at what it's doing, and just the experience of knowing what does it need in order to fix some of this stuff. And on the tweeter, there's a couple of notch filters that are bringing down peaks that's in that tweeter's response. I didn't have to do any notch filters on the mid, but it's aggressive in the way I'm rolling it off. There's a small cap and a big inductor, and then there's a few parts after it, but it's basically just knocking all the top and all the bottom out of it, and to the point where we're using that to pull the level down. So it's a little creative in what I did. The woofer, we had to put a third order filter on the woofer to get all of that hash out of it before it got up into that breakup region. We couldn't use a low order filter, or couldn't let it play up very high, because then all that ringing would be right there in the music. We don't want to hear a bunch of ringing and breakup. We want to hear smooth response and none of that ringing and breakup. So, all right, let's look at some of what I'm really proud of here. Let's look at the vertical off axis. Let's look at going up. We're taking the measurement exactly like we did before. Here's the new vertical off axis and the old vertical off axis. Now take a good look. This is, again, measured the exact same way. We're starting out at this level, and we're moving up 4 inches per measurement at 1 meter. So as you can see, it's now maintaining a really flat response over a wide range, and it kind of took a while to get a crossover design to where the crossover kept the drivers in phase over a wide range. So you could go up or down and it not change the phase relationship very much. So we're on phase at perfect phase on axis. So either direction you go starts going out of phase slightly. So we're covering a big range of keeping things in phase. And let's look at another one here. This is the off axis going down. So I'm going from here, I'm going down 4 inches per measurement, and it's still extremely good. Great, like I said, great coverage range all across. Now let's look at the horizontal off axis, and let's look at the new horizontal off axis and compare it to the old horizontal off axis. As you can see, now we're looking at a little bit of the tweeter dropping off as you get off axis at the very top. That's why the top end is dropping off. The further you get off axis, the more this thing tends to beam. It's going to, because it's a tweeter that's this big around. If it were a dome tweeter, something smaller, it would have a wider response region, wider range in the off axis. So that's why we see the top of it start to drop off a little bit. Where we see that little drop out in the 3 to 4 kHz region, 3 to 4 5 kHz region, it's a little bit of cancellation between the two as you start getting really far off axis. And it'll be a little different going in each direction. I should have measured it both ways so you could see it both directions. But it was kind of pretty close to the same. So the reason it's doing that is because these are offset horizontally. Anytime you offset drivers horizontally and you start moving left or right, you're changing time arrival from one to the other. And it's dropping out a little bit, but nothing like it was. Before it was dropping out, there was comb filtering and cancellation that caused a peak and a dip, and another peak, and then you moved again, and now you had a dip and a peak and a dip in a different position, where you've got comb filtering going on at different frequencies, and it was a total disaster. And now it's pretty smooth. It's dropping off pretty evenly. You could get 10, 20 degrees off axis, and it's not a huge change in response. So now we've got an in-room response that's much more consistent all over the place. And I would recommend when you upgrade these things, get them on some stands that's going to get your ear at this level. You want to be right about here with your ear level. And that's going to give you a sweet spot. And it's going to kind of move these up into the room to where they're kind of more in the middle of the room. You don't want to take a speaker like this and set it on the floor. I know that was common back then. You set the speaker on the floor and you just cranked it up. But come on. Get this thing up off the floor. Get it out in the room a little bit. You're going to get some pretty decent imaging out of this because the time arrival of the drivers is fairly coherent now. Also, let's look at the spectral decay. And let's look at the new spectral decay compared to the old spectral decay. Notice how much cleaner this is, how everything is dropping off smoothly. A little bit of stored energy right there in that mid-range driver. I couldn't get it out. I just couldn't pull the mid-range level down anymore to get that lower. But overall, it's good now. It's nice and balanced. It's not like it was before. Lastly, the super tweeter. I know you guys are wondering, like, why are you talking about that super tweeter? If you cross this very low at all, like if you let this get down well into the top octave, as soon as you move left or right, it'll completely cancel out this tweeter. Like you can't use two tweeters and not have a tremendous amount of comb filtering in any direction. So we put a pretty small cap value on this thing. In fact, we put a 0.1 microfarad on there. And I know that sounds really small, but the impedance is pretty high, so it's not as small as it sounds. But it's allowing it to have some energy in the maybe very top half of the top octave and there and above, like from 16, 18 kHz to 40 kHz. It's got some energy there, and it's going to help create a little bit of space and ambience. It's there, but I didn't let it play down low enough to where it would start really canceling into this thing. That little cap value on there just knocks most of everything right out of it. Let's look also at the impedance curve. Let's look at it the way it was before. And if you look at it there, you can tell they basically built it like as a two-way speaker. There is values were calculated electrically for sure. If you look at the new impedance curve, let's do old and the new below it, you can tell that there's some things going on there electrically it's changing the impedance a little bit. It's making some corrections to the frequency response. But overall, it still measured a pretty smooth response all the way across. And the output from the port, let me see if I can read this here, is tuned at 36 hertz. And the impedance, I want to say, dropped to, I don't think I have it marked on here, but I want to say it dropped to around 6.5 to 7 ohms. Let's see, 6.1 ohms at the tweeter end was the lowest it dropped from the factory. And we're not any below that now. So pretty easy load to drive. I did hook these up there when I had them on the test rig and I was measuring and testing and I had all this finished out. I did hook it up for a while and listen to it with the network on it, and I must say it sounded a lot better than I thought. I was really afraid because of the age of these drivers, the design of these drivers, that it just wouldn't have any resolution or detail. And maybe, yeah, compared to some planar magnetic tweeters and top-level dome tweeters, it may not have the resolution of a modern speaker, but it was not bad, and it sounded smooth. Of course, it measures really smooth, and sounded really balanced. And overall, it sounded really good. I couldn't believe it. So here's what I came up with. This is all new crossover parts. Throw all this in the garbage. You can reuse this cup and mount a set of tube connectors right here. You're going to use some tube connectors to hook everything up through and run the crossover down to the floor of the cabinet. It's quite a bit larger than this because we're looking at big air core inductors and big poly caps on everything. So it's going to take up a lot of the floor space in the bottom. All new crossover parts, all JB caps, bypass caps, all US coils and inductors, and the Dayton copper resistors. We like those little resistors. The parts and the tube connectors, all new wiring, 3 sheets of no-res, your solder, your heat shrink, the wiring diagram, everything you need, $739. And that $739 is exactly what all the parts cost. So if you thought, you know what, I'll just shop this stuff around, I'll just go buy these parts from this company or that company, and by the time you shopped it around and played shipping from different companies, you'll pay more for these parts than if you bought the kit. I'm charging you exactly what the parts cost. I'm not adding a big bunch of fluff somewhere. We do this as a service. This is fun. I like doing this. That's what it's out there for. And it gets guys into the DIY market. People want to try something, have a fun project, take an old speaker like this and restore it to way past original levels. This will be a fun one. And there's also a Sonicap upgrade that you can put Sonicaps in the tweeter circuit, which will bring the resolution levels up another level. It's going to be a $180 upgrade to change out those 4 caps to Sonicaps. But it's there for you if you want to take it to that level. Now, you will want to cut some little diagonal braces. I'd say get some 3/4 inch material, run it through your table saw, cut it into 3/4 inch strips. So you got 3/4 by 3/4 diagonal, cut the ends. Glue those things in from the side to the back, from the side to the back, from the side to the top, and at least give some structural support onto this thing so that it will quit resonating so wildly. Then once you lay in the no-res in between your little braces that you've glued in, it will damp out any of the remaining resonances from the smaller panel sizes that you've made when you've put the braces more in the middle of these things. The bracing's going to help a lot. The no-res is going to help a lot. It's going to tighten it up. It won't buzz anymore. Right now, I can run test tones through this thing, and this thing will buzz like a bumblebee. At certain frequencies, it will light up. All that bracing and that no-res will just kill all that, and you'll be able to hear much cleaner, tighter bass, cleaner vocals, better across the board. And all it has in it right now is just a little fiberglass insulation on the walls. There's nothing really in the cavity. So adding the no-res is going to slow down the airflow in the box a little bit. Add back in a little polyfill or fiberglass insulation, a loose fill right behind the woofer, and the box will act as if it's the same size it is now. Even though you took up a little airspace with the braces, when you slow down the airflow in the box with more insulation, it makes the box act as if it's larger. So it's very easy to do all that stuff and not take up airspace in the box. It'll work out fine, trust me, no issues. It'll sound a lot better when you tighten up that box and then add back in some insulation to get the volume back. So that's it for this one. It was a fun one. I love digging into these old vintage speakers. This one's definitely worth saving. If you've got any of these old Pioneer speakers and the drivers are in good shape and everything works, build this upgrade. You will really enjoy it, and it really transforms this speaker into a speaker that will really hold its own against a lot of the newer stuff out there. I promise you, it will hold its own. The way they made these drivers and the material that they used was not bad. It's got a nice, smooth sound. All you have to do is fix the problems, and we have the tools and the ability to do that. So we've done it. All you got to do is buy the kit, follow the instructions. You'll have a blast with it, I guarantee you. That's it. I hope you enjoyed it. Hit the subscribe button if you haven't. I love that you guys subscribed. You'll get notifications when the next ones drop. Hit the like buttons too. Hit that a lot. That helps move us up in the search engines there where we're seen a little bit more on YouTube. That's it, and See you guys in the next one.